Karl Herleman and Jani Syed actually will be speaking next. Karl actually is the VP of IT Strategy and Innovation at Management Science Associates, Inc., right here in Pittsburgh. He's got over 25 years of experience in IT and enterprise software development. He holds an MBA from Barry University, an MS in Computer Science from the University of Central Florida, and a BS in Computer Science from Penn State. Karl is a senior member of the IEEE, a longtime member of ACM, and on the board of Pittsburgh DataWorks. Jani actually is a senior enterprise architect at MSA who will be speaking after Karl. Previously, Jani has held key architectural positions in finance and the telecom industries. He's providing architecture, design, and leadership to big data projects, and really, Karl wanted me to make sure to mention that he's key in building big data teams at MSA. So at that point, I'm going to turn over to Karl.
Thank you. Good afternoon, everyone. So text analytics has always been an important research area in computer science, natural language understanding, and artificial intelligence. And of course, over the last 20 years, it's gained real importance in consumer and enterprise search tools. But overall, I think it's pretty much not been really penetrating the enterprise, right? Its enterprise use has been pretty abysmal. But I really think that that's going to change. That's going to change pretty rapidly over the next couple years. It's probably one of the most exciting times with text analytics that I can remember, right, in IT and in computer science, because you've got distributed, large-scale technology ecosystems such as Hadoop and UEMA that can provide this incredible, innovative platform where we can have data management innovations and everyone can afford it and everyone can apply it to their everyday business needs. But with all that said, I still don't think it's quite where it needs to be, right? Last month, we were at the Strata and Hadoop World in New York City, and there wasn't a single session on UEMA and Hadoop. And UEMA is Apache's unstructured information management architecture. And it came out of IBM. I wasn't here for Jerome's talk, but I'm sure he mentioned it. And I think that that wasn't a part of Strata, and that's a real missed opportunity. We all hear about Watson, and we hear about question answering, and we hear about cognitive computing, and that's all very exciting. But again, where is it? And it's in the enterprise. It's not very commonplace in the enterprise. So, but I'm still very excited. And why am I excited? Well, I want to take you on a little journey back in time. Let's talk a little bit about text analytics then, and then now. And maybe you can get excited like me, and I'll appeal to you to help me make UEMA enterprise ready on Hadoop. So then was the 1980s, and Arnold was all over your sci-fi movie screens. And sci-fi has always had a tight connection with computer science, right? And it definitely attracted a lot of engineers into natural language processing, understanding, and AI. The issue there is that this stuff wasn't easy. So even though it attracted a lot of folks, there was absolutely no infrastructure at the time to support really good text analytics. Most natural language processing text analytic algorithms are multipass, they're high complexity. In general, they're very hard. And you really need some computing power to really process them. And the problem is you didn't really have any. I remember spending lots of time cobbling together a bunch of Spark stations trying to give myself enough compute power in order to run my algorithms. I did it, but I'm positive it really wasn't good. I also remember not having electronic corpora available, right? So I, like many other students, would spend nights and weekends typing in or scanning and correcting some type of corpus just so I could test my algorithms. And then, of course, once I digitized everything, I ran out of space because we were really talking about megabytes or hitting quotas at that time. Then I tried to go find some text components, right? Some parts of speech or some taggers or some parsers. And you had to comb every research institution's websites, if they even had them, or crawl all these sites. And it was CMU, it was MIT, it was Stanford. And they were all written in different languages, and they were all on different platforms, and there wasn't anything called GitHub. So it took you weeks to try to find all the pieces and parts and put them together. And then once you did put them together and run them, the quality wasn't quite there, right? Because they didn't have these large, massive data sets to train against. So I remember using first time the Brill tagger, And with the Brill Tagger, it was trained on the Brown corpus, which was one of the first big corpus available. And every time when I applied it to my problem set, it always thought that run was only a verb, right? So, no, and it didn't matter. It wasn't just the Brill Tagger. It was pretty much any kind of stochastic or rule-based tagger that you wanted to use. Just didn't have the quality that you need. And largely because there weren't any lexicons, or not very many of them, right? And if you did have them, it didn't have very robust lemmatization or stemming. So, and of course, if your tagger or your lexicon wasn't very good, then forget about your parsing, right? At best, it would not do well, and at worst, it just wouldn't even work at all. And then came a breakthrough. We got WordNet. WordNet came out of George Miller's work and out of Princeton, and it was a great breakthrough because it gave you a really good lexicon. It gave you all kinds of relations between words, synonym sets, antonyms. It gave you ontologies. It gave you relations. But again, when I started to apply it for my real-world work, it kept telling me that capital P parks was just a plural noun for a recreational green area, and it had no idea that that was the last name of a pretty famous historical American figure. So, and of course, because of those limited corpora, the statistical methods were really not widely used, right? It was mostly symbolic. So let's fast forward to today, or at least the last 5 years. I really still like the Terminator, and I have 3 kids. The only movies I'm seeing is Frozen, so you're on your own there. I really don't have a clue. But the biggest change is that everything is digitized right now, right? So you got the Google Ngram corpus, you've got Usenet corpus, you got Project Gutenberg, you've got 46,000 free ebooks out there, you got Time Magazine corpus, you got wikis, and you got the general web to be your playground. So there's tag corpora, there's annotated corpora, there's concordances. In fact, there's so much digitized text and so much unstructured information that is being created every minute that there's no way that you could do what I did years and years ago by cobbling together a couple of computers to really process it all. But luckily, you don't have to, right? There's this great, absolutely powerful framework called Hadoop, right? And whether it's Cloudera, Hortonworks, MapR, or even some just plain old Apache, right? It provides you this great, pretty much free, really reliable and scalable infrastructure on commodity level computers. And if you don't want to download it and stick it on your own, you can just use it in the cloud, right? You got Amazon, you got Microsoft, and you have Google. Then there are these incredible toolkits. So where I had to spend all my time reading and download or looking for papers on components, now you have a natural language toolkit. You have GATE, which is a general architecture for text engineering. You have OpenNLP from Apache. And they provide component libraries for stemmers, part-of-speech taggers, parsers, named entity extractors, lexicon, thesauri, summarizers, tokenizers, all of the above, right? Translators. Even if you just look at for named entity extractors, pretty much every research institution out there will have one, and they can be rule-based and grammar-based, and there's just a plethora of available options. And the quality of these tools has improved incredibly, right? Why? Because of the massive amounts of text that now you can train them on. And symbolic methods largely gave way to statistical methods, and now they're kind of going back together with some deep learning approaches, right? And then there's UEMA, which is the unstructured information management architecture. You can take any of those components, you can wrapper them, you can make them into analysis engines, you can then coordinate those analysis engines using a common annotated structure to pass between them, and you can really build, relatively easy compared to long ago, a nice text processing pipeline. Really, really powerful stuff. What took me weeks and weeks and weeks to do years ago by downloading and compiling and really took me away from my real research area, which was trying to determine out how do you resolve anaphoric references. You ended up spending all your time just doing all this busy work, and now you've got something like UEMA, which really provides you that incredible abstraction to start to put together a processing pipeline. And then lastly, you've got this millions of terabytes of unstructured data, so you need more than just UEMA. You got to stick that on Hadoop. And there are lots of ways to do that, right? There's a project out there on Apache project called Behemoth. You can use Solr, which is one of the enterprise search tools, and even Spark. Now I'm going to turn it over to Jani, who's going to real quickly go into what exactly our architecture is at MSA with this technology.
Thanks, Karl, for giving us the history of evolution of text analytics. While Spark and Hadoop are the big data platform that enables data-intensive distributed applications to work on thousands of nodes and petabytes of data. But they are not inherently a text processing platform per se. UEMA specification defines platform-independent data representations and interfaces for text and multimodal analytics. UEMA is a framework that provides APIs and then abstraction layers and orchestrating different types of text analytics. And definitely, UEMA is not a toolkit that you can take it and run it in any platform. UEMA basically has three components if you're building an analytics engine. And as you know, like MSA is big in analytics. And this analytics engine consists of collection reader, output collector, and cache, which is common analysis structure. A collection reader, like as you have seen here, it can get the data from spreadsheet, XML, email, logs, and so on and so forth, and then serves up the documents or pipeline to do the analysis. And then the output, it could be a dashboard here, but which takes the results and spits out to a database or to a file system. Common analysis structure is a data structure, usually one per Docker unit of work, and holds the content analysis of the document. The content of the document is usually seen in a view, which is a nice abstraction. Often the data, you can have multiple different formats, XML, JSON, and so on and so forth, and you can have end up multiple views. And it's good to do if you're doing some comparative studies and so on and so forth. And at MSA, we have created a gold standard labeled corpus for manufacturers, distributors, and retailers. And it provides us a standard view that gives us the basis for comparison. And when you're doing the analysis of the doc, it's represented as annotations, tokens, sentences, paragraphs, syntactic structures, classifications, and so on and so forth. And in a NLP community, it's often known to create complex pipelines for processing. For example, a Perl module is feeding into a C module with a different file format, and so on and so forth. CAS has a nice way to orchestrate different kinds of analysis on the same doc at different stages of the analysis. And it has a user-defined representation, which is quite expressive and flexible, and basically used to define your own annotations that you can perform on. It also allows to write feature extraction libraries which are generic across different systems, instead of re-implementing the same kind of low-level lexical features. One of the biggest headache that we've seen using UEMA implementation is that the configuration is very complex and very tedious in CAS. When we looked into implementing UEMA on Spark, we found out it's not viable because the UEMA components are not serializable. We had to do a lot of work around to make it happen. And when we looked into UEMA implementation on the Hadoop, we found a project called Project Behemoth, and Behemoth's modular architecture simplifies the development of custom annotators. And all these custom annotators are based on MapReduce paradigm. Behemoth tries to simplify the development of the document analysis at large scale, and also provides the reusable modules for data ingestion, text processing, and generating output to the external tools. Behemoth takes care of the need to write any MapReduce code. As you know, writing a MapReduce, you need to be a good Java programmer. And it also handles things like extracting the content from different PDFs, Words, and Word files, and so on and so forth. and outputs to a Hadoop friendly manner. Like imagine like you are running Apache Tika in MapReduce framework, and you can also send those outputs to Solar or Mahout and Gate or any others, and also it allows to annotate the intermediate results. Behemoth isn't super sophisticated in terms of doing the ETL, but it's very flexible and very lightweight, and you can create your own annotations, and you don't have to worry about writing mappers and reducers. Basically, what you do is like create UEMA pipeline as mappers, and then export it and copy to the SDFS, generate the corpus, process using the pipelines, list annotations, convert your annotations to text. As you know, MSA caters to different domains from medical to retail. We have created different models for processing on each domain, as you can see the modeler there, and we implemented we are trying to implement UEMA on Hadoop that provides analytics for manufacturer, distributor, and retailer chains. One of the, as we have seen in the previous presentation, how Target identified the 16-year-old pregnant. And we can show, how we can use, usually the retail chains, holds historical data in different databases and different sources, and in different formats. Some of it is structured, some of it is unstructured, and the data includes from purchase records, feedbacks on stores, and analysis of this historical data reveals information about the buying patterns for a particular customer, purchasing preferences, attitudes towards competing retailers, and so on and so forth. And we are planning to put all this historical data into SDFS and do the classification using the UEMA and created predictive algorithms using Mahout. And probably we can show Target how to do it faster and cheaper.
So to wrap it up, I think it's been a pretty incredible transformation over the time from Terminator days. But again, while these tools are really improved, I'm really hoping to step it up a level, right? To take it and make these truly enterprise ready. And here's a lot of the areas that everyone should be able to utilize UEMA on, right? Data cleansing, matching, integration, master data management, and any type of data warehousing can be absolutely improved by using UEMA on Hadoop. So we absolutely are really interested in making these enterprise ready. Thank you.